our session on operating your terminal sustainably with tank top solar. My name is Karen Schacht. I'm with ILTA. We have two speakers today, Jin Jin Huang and Chris O'Neill. Jin Jin is head of solar strategies at Hartree Holdings, where she is building a new business vertical focused on solar development across Hartree's subsidiaries, including Sprague Solar. With nearly 2 decades of technical experience, she's an expert in energy systems, electrical grids, and advanced building design. Her background includes design, construction management, and commercial sector solar and storage development. Chris serves as Vice President of Engineering at Sprague Operating Resources, bringing more than 20 years of experience leading energy infrastructure operations. His career includes senior engineering and leadership positions at Anadarko Petroleum, Freeport McMoran, and the U.S. Coast Guard. Chris is a licensed professional engineer and holds a Master of Business Administration and Master of Science and in Mechanical Engineering and Bachelor of Science from the U.S. Coast Guard Academy. So, really look forward to teaching.
Good morning, everyone. Thank you, Karen. We have been installing solar on top of our tanks since 2018, so I'm very happy to be here speaking to you folks today. And don't see familiar faces, but we have been speaking to some of you guys about our solution, and we're here to tell you how it works. Today I'll be covering what is solar on top of tanks, right? And then I'll go through some of the benefits, and then I'll review some of the innovations that we put into engineering it. Then Chris is going to cover some of the operational considerations and inspection considerations, and then I'll wrap up with some safety features and sample projects. And then we'll have some Q&A. So what is solar on top of tanks? Unlike traditional solar systems, you do not have mechanical attachments, you don't have ballasting. It is a thin film technology with adhesive on one side, actually a panel. So it spins out like this, and it has adhesive on one side, and it adheres directly on top of tanks. And then the rest of the system is very similar to a traditional solar system. You string them like regular solar, and then it's designed at 1,000 volts DC, and it's an inverter-based system. The images on the left here, you can see the top image is from our South Portland terminal, and then the bottom image is from our Albany terminal. The system has a full warranty for parts. We have 20 years for the solar panels and 10 years for the inverters. And the modules are designed to withstand hurricane strength wind and up to 1 inch of hail. What that means is when the parts fail due to some inherent flaw within that time frame, 20 years for modules, 10 years for inverters, the manufacturers will cover the replacement of those parts. And then after that, it doesn't mean you'll die immediately at year 20 or year 10. It just means if anything happens after that, your system will continue functioning, but you'll have to replace it at the end of that. For those who are not familiar with solar systems, I like including these figures just to show you how it actually impacts your energy use. These are figures constructed from our actual energy profile from our South Portland terminal. So the blue line that you see, the blue line is what the energy use of the terminal is normally without any solar. The orange line is solar, so as the sun comes up, you see solar produces, and then it comes down at night when the sun stops shining. And then the gray is the energy used at the terminal after solar. So the left is the typical winter profile. As you can see, there's not a lot of sun, but you do have some offset. And then in the summer, you have more sun, so you're producing more than what you need during the day. So if you follow the curve from the edge of the curve, when you have net metering, what happens is when solar produces more than what you're using as it goes up, and you see the gray line dips below, that means you're pushing energy back into the grid. And then at night, as the solar stops producing, your usage from the grid ramps back up. And what net metering does is at the end of the month, the utility will net meter that. They will charge you based on the difference of how much you push back and how much you take in, and that's the delta. And net metering is great that way because whatever you pay, 18 cents or 7 cents or 9 cents, that's how much credit they give you for that energy that you produce. And that's why solar is so valuable. So some of the benefits, aside from that energy savings that I just showed you in the profile, you have lower carbon emissions. For those who does report for scope 1 and scope 2 emissions, when you have on-site solar, that directly reduces the reporting for your terminals. And it reduces maintenance. Prior to us actually applying the solar, we will survey the existing condition of the tank. So if it's a great tank, fine, we just do some cleaning and then we put the modules on top. However, if it's an older tank and you have some signs of corrosion, it hasn't been painted for a long time, we will sandblast and prep the tank such that we can repaint it and put solar on top of it, so there's no maintenance on it for 20 years. So we don't lift the panels, do whatever you need to do, right? This protects the tank from that maintenance. You have improved resiliency. So on-site solar will give you a better power quality, depending on how much you can offset. So the solar, for those who are engineering needs, like me, it produces that unity power factor, unless the utility tells you otherwise. You're at unity, so you're using all of that energy you're using. Some utilities who need cable or support will make you change the power factor at the inverter level to lower the unity, but so it helps you improve your power quality having that solar directly in the cycle. And of course, it stabilizes your future pricing. Whatever you're not using from the grid, you're not exposed to the volatility of rate changes. So whatever you produce, like some of our terminals, we're offsetting as much as 60% of the energy use on site. So 60% of that is protected from volatility of the grid price changes. Since we've been approached back in 2018 with the idea of solar on top of tanks, we're like, why not, right? Solar on top of tanks, you have unused real estate on top of the tanks. It's always exposed to the sun, so there's no shading above the tank. And also, you generally, at least our terminals, it's a high energy intensity site. So you can produce on site using unused real estate and using sun energy. So we thought, great. But then when you think about, okay, solar is a recognized and understood technology, but when you apply it on top of tanks, and for those engineers in the room, you do need some engineering innovation to make sure that the system works. You can't just slap some, panels on the tank, connect it, and say, okay, everything's great. So we have been through trial and error be able to fix and come up with a solution. And because of that IP that we've invested in that, we've been able to have exclusivity agreements with our module suppliers, specifically for tank top application. So that technology you can use on other commercial roofs, for instance, that cannot support the weight of traditional solar systems. But for us, we have exclusivity for tank top application because of the IP that we've invested in. And the solar system that we install, you can operate a terminal with minimal impact while we're installing and getting the operation the life of the system. And then we're also designing the system to accommodate the unique needs of tank installation. For example, the inflow technology can accommodate inspections, and as I mentioned earlier, it protects against the weather elements once you have it on top of the tank, and we've already cleared the corrosion from the tank before we apply it. And we can speak to it later. And for those who maybe this is new, and you might walk away just remembering a few things that I say today, I think that what I say in these couple slides hopefully will be some of those things. Maintenance. Our maintenance protocol is conducted by internal staff because our folks understand terminals. So instead of having a traditional solar O&M company performing the O&M, we will perform the O&M if we install the system on your site. And operations. I think this is something we want to drill in today is it does not impact operations at the facility. We can have full operation during the construction period while we're installing these systems. And cost efficiency, I think, you can have a great idea, but if there's no payback, then there's no conversation. Right? We've been able to create a system that is cost effective, and in fact, I can even say it's the most cost effective in the system. I don't think anybody can beat us based on what we've been investing in resources and how we've come up with our solution. Safety procedures. Safety is so important to terminals. I mean, safety in general, but particularly in terminals because we have liquid fuel storage. So we have put in a lot of effort in safety procedures in our design. I have more slides on that later in my presentation. And then inspections. Chris is going to go into more details on inspections later in this presentation. But you can do inspections as well. You don't have to forego your API inspections because now you have solar and you can still meet normal operations and reporting requirements as usual. Now I'm going to go over to Chris for the next few slides.
All right, good morning, everybody. So as far as operational considerations go, and probably you've heard this a few times now, the big question we always get is, does this impact operations? And generally speaking, the answer is no. There's not a significant impact to operations because these panels, these systems don't have moving parts. They're adhered directly to the tank top, and so not a significant impact. That said, there are some specific areas of interest that when we're designing these systems, working with Jin Jin and her team, we want to make sure that we consider. So one of the great things about these systems is that you can kind of customize the layout of the panels however you want. I equate them to peel and stick tiles like you're renovating your bathroom. You can put them wherever you need to put them. You can leave areas exposed wherever you need to for access to any sort of appurtenances, gauge hatches. If you have common areas that your operators need to transit to get to a particular inspection point or something like that. Those are all, those can all be worked into the design, and so those areas will always remain accessible. And I feel like that's an essential part. We've done a couple iterations of these systems, and that was an essential learning for us, is to make sure you start with, at the outset of the design of the system, and you identify those points, and then you include them in the design, and it's not an issue. In terms of training, once again, there's not a lot of moving parts here, so Jin Jin's team will provide really sort of essential training for terminal operators, which is really to understand how the equipment works, how it's connected, but it's not particularly complex. You're taking solar panels, connecting them together in strings, and then connecting those strings together to inverters at a very high level, right? And then those inverters are kind of the only piece of equipment that needs really interfacing with that on occasion. And it's more for terminal operators, it's more like an on-off type of thing. Is it working? Yes. Is it malfunctioning? It's like calling Comcast and the reset button. That's kind of the 90% of the ways. I know I'm oversimplifying. But that's going to be most of your your maintenance tasks are going to be to turn on the window or that back and forth. So really simple for these systems. And then the other thing is in-service inspection and monitoring, and there isn't a specific requirement that these panels be monitored or inspected, but it's good practice for your terminal operators. If you say have a monthly inspection protocol for your tank farm or a weekly inspection protocol, whatever it may be, to just incorporate this into that same inspection protocol as another inspection point. So it's really a visual inspection. It's looking at the panels, making sure that you don't have any that are de-sticking, unadhering to the tank top. If that can occur. If you have something like that occurring, then you identify it, and the terminal manager calls Jin Jin's team and says, "What do I do about this? We'll come out and fix it, or it's not a big deal. We'll get it at the next annual inspection." So, really not a significant requirement associated with those ongoing inspection protocols. It's really how much do you want to take a look at the system? How much do you want to monitor? One of the big questions we get though is how does this affect API 653 inspections? Specifically, obviously, the tank top condition aspect of the API 653 inspection. Of the tanks that we have panels on, we currently have 3 tanks with panels on them. One of them is in service and 2 are out of service, are temporarily out of service. And the 2 that are temporarily out of service, we're not currently conducting ongoing API 653 inspections on. But the one that's in service, we've gone through out of service and an in-service API 653 inspection protocol. What does that involve? Well, first part is you meet with your inspection company and you say, hey, this tank has solar panels on the roof. And then they scratch their heads and say, what does that mean? And you take them up there and they look at the roof of the tank and they see that there's these panels directly adhered to the tank top. What does that mean in terms of taking thickness measurements and things like that for the tank top? Well, you still can, and you can do it however you would like to do it. If you want to take a random UT thickness measurement on every single sheet that's on the roof, then that can be accommodated in that once every 10-year inspection cycle by removing a panel and then reinstalling it. But you may not need to do that. It all depends on how much you want to dig into the inspection of the tank top. For us, before we install the solar systems, we made sure that we got a good scan of the roof beforehand, and so we had a good indication of what the condition of the tank top was. And then you make sure you have a very robust coating on the roof, which is part of the installation process. And then you have these solar panels that are protecting the paint from UV, which is the primary degradation cause of damage to the tank top, of the paint on the tank top. And so if you had a solid roof and you had good paint, and then you have these panels on top, you really don't have anything to worry about for that 10-year span. And when your next inspection comes around, then you work with the inspection company to determine which panels you want to look at and which ones you don't. It's really kind of that simple. It's not an issue, and it's not a problem for the inspection companies that we work with. And if you ever ran into a problem with an inspection company, if it was different than the one that Sprague uses, then we'd be happy to interface with that company and come up with a plan for addressing it. So that's really one of the most common questions we get is, how do I do a 653 inspection? The answer is, you do it. It's just a slightly different protocol than you would have for a non-solar installation.
Two things from this is I find Chris's voice very soothing, and I also notice he has drank a lot less coffee than me. So I realize how fast I've been speaking after hearing how Chris has been speaking. And he brings up really good points about our design. We don't design this in the black box. We work very closely with our engineering folks. We work with our terminal folks, and everybody gets feedback to make sure, in addition to all of these things that we have already taken into consideration, maybe there's something unique to their terminals and something that you guys do that's a little different at your terminals. And also, we have 3 feet wall aisles every 2 rows of panels. So we keep clearance around the gauges and we keep clearance around the vents. So it's, you can really access these things really easily. So safety is so important, and also we want to make sure that our first responders feel comfortable coming on site in case there is an event. Even if the event doesn't involve the solar system, we want to make sure they understand, A, we have solar on site, and 2, it is completely safe for them to approach. And not only for them to feel comfort, but also for us to ensure the safety of our folks and also first responders, the firefighters that come to the site. So our system is designed to class 1, it meets class 1 due to electrical requirements. And as I mentioned earlier, we avoid the gauges and the vents on top of the tank so that we can have regular access. what's actually happening with the solar system. And it also has built-in fault protection. So when there's an arc and ground fault, the system will automatically shut down. And when we do have a fault, and we will have a notification, when our team will look at it remotely and determine if this is a fault that we can clear remotely, or is something that will require on-site inspection and to clear on-site and make sure it's safe before we re-energize the system. And, you know, isolation is the number one thing for making our first responders feel safe. We have located our converters outside of the hazardous classified environment, and each tank is divided into 2 segments, and each segment has its individual disconnect. So it can be, so in addition to like every solar system, when you interconnect it, you have to have a single disconnect switch for the utility, so that there's a kill switch from the utility if they want to de-energize it, they push the button and the whole system's off. But then in addition to that, we've added another layer of isolation where we have another disconnect switch where it isolates the energy on top of the tanks. So because our tanks are metal, we want to make sure solar panels are going to produce as long as they're exposed to the sun. You can't switch the panels off, right? That's the nature of solar panels. But you can isolate the system itself so that the DC energy doesn't exit the tank. So we have isolation on top of the tank in case there's a storm event or something and you need to approach the tank. We want to make sure that you can approach the tank knowing that there's not going to be any energy that can transfer onto the tank. So we have an additional isolation layer for that. So that's where our folks are pretty comfortable, and our departments are, you know, pretty happy with the solution that we put in place. So this is my last slide. I want to end with giving you some insight into our next project. The next, as Chris said, we already have 2 projects that we've built at our terminals. Our next terminal, we have 2 more terminals that we're building. One of this is at Bridgeport. It's a 600 kW system, and the annual production is roughly 600 megawatt hour. That's actually almost, that's about 65% of our terminal energy use. So we're going to save estimated $96,500 a year. Energy costs in Connecticut is pretty high. And then over the lifetime of the system, we're anticipating a 2.2 million savings from the solar system. Oh, and that's the image you see on the right. That's how the solar system looks like on top. You can see, as I mentioned, it's divided into 2 spheres. And then you can see those white lines in between. Those are the walking aisles between those. And I have my contact information, Chris's contact information. Also, our director of business development, David, is here. So his contact information is here. So we welcome to email him with us any questions. Now, bring Karen back up for Q&A.
Thank you, Jin Jin. Thank you, Chris. And before I ask any questions I have, I just want to throw it out to the audience. Does anyone have any questions about this system or how it might work for you?
Yeah, a few questions. One, you might have covered in my own technology videos, but can you walk on these? Does that cause any damage?
So these originally, so the short answer is yes, you can walk on them, but they actually, because our folks wear steel-toe shoes and they're wearing safety shoes, they are very hard to hit. So when you land on a seam with those boots, you can actually cause some damage to it, so we encourage not to walk on them. If you do have to step on them for whatever reason, that's fine. The system will still work. And that's why we've designed the system with walkways, so that you can do all your access to the top of the tank without having to step on them.
And then periodically you need to clean them off to maintain efficiency on them, or the rain, normal weather kind of keep things keep off.
Yeah, so similar to other solar systems, generally we don't need to clean them because the rain is enough to clean them. And when we model the performance of the system takes into account soiling,
as far as the wiring goes, it's you said 1,000 volts in the city, so essentially we're working with a smaller gauge cable to run that to the inverter, right? That's the idea.
So we do have special conductors that we're running overhead to bring it to the inverters. So all of the wiring in our system is rated for 1,000 volts.
Okay, so everything's run overhead, we don't run a conduit with our cables, right? Or just everything's available.
That's correct. We found some of our earlier designs, we had conduit running down the tank and then we trenched across in the night area. And it's just too much. You know, you don't know what's underground and you know the welding around. And it just so happened when we installed our first 2 tanks, as Chris mentioned, you know, 2 of them were out of service, and then the other one that was in service. It so happened that we were servicing it, so we were able to catch it such that there was no product in there while we were welding to hold the inverter, the conduits. So we found that that is not sustainable. You can't count on, you know, installing a system year round and expect the tank to be out of service. So that's what we're running overhead.
Okay, thank you.
Sure.
Jin Jin, I have a couple of questions. Maybe I can combine this, a couple of these. So I guess I was wondering what kind of storage tanks or that sort of system, and you know, would the installation process require inventories to be taken out of service?
Generally, we've been installing on top of fixed roof tanks. So if your roof is a floating tank, we can't do that. We can install on top of a distillate and gasoline tank.